Hi, this is Professor Bob Young, and in this instructional video, we are going to talk about solving linear application problems involving geometry, motion, and mixture. So let's start off with just some general rules. Whenever you attack a word problem or an application problem, step one, read the problem carefully until you understand what is given and what is to be found. Step two, assign a variable to represent the unknown value. Use diagrams or tables as needed. Write down what the variable represents. If necessary, express any other unknown values in terms of that variable. Step three, write an equation using the variable expressions, or solve the equation. And step five, state the answer to the problem. Does it seem reasonable? And step six, as always, in all equations, check the answer in the words of the original problem. So let's go ahead and start out with a geometry problem here, finding the dimensions of a square. So it says, if the length of each side of a square is increased by 3 centimeters, the perimeter of the new square is 40 centimeters more than twice the length of the original square. Find the dimensions of the original square. So when we read the problem, we must find the length of the original square. So on the left, we're going to go ahead and label the sides of the original square x. And the square that's 3 longer, we'll go ahead and call x plus 3. And we're just going ahead and showing that again in this graphic here. So if the original square side is x, the square increased by, now you have to know increase means add, is plus 3. So there's another look at that. So it says, since the length of the side of the original square is to be found, let the variable equal this length. Write a variable expression for the perimeter of the new square. The perimeter of a square is 4 times the length of a square. So the perimeter of the new square would be 4 times x plus 3. Now, writing the equation, it says the new perimeter, 4 times x plus 3, is equals 40 more than 40 plus twice the length of the original square. And then go ahead and solve this equation by distributing, and we will find, if we take letters left and numbers right, x will equal 14. Each side of the original square measures 14 centimeters. Now let's go back and see if that makes sense here. All right, it says 1, the length of side of the new square, 14 plus 3 equals 17 centimeters. Perimeter would be 4 times 17 equals 68 centimeters. Twice the length of the side of the original square is 2 times 14, or 28 centimeters. So since 40 plus 28 equals 68, that answer makes perfect sense. All right, next we're going to talk about motion problems here, or some books call them distance problems. And we know that from previous courses and so forth, and if not, here is the formula for distance, or motion as they like to call it here. Distance equals rate times time. So we'll go ahead and look at that. And also, you can solve for other variables here and say rate equals distance divided by time, or time equals distance divided by rate. It's all in how they word these type of problems. So let's give a problem here. It says Maria and Eduardo are traveling to a business conference. The trip takes 2 hours for Maria and 2.5 hours for Eduardo, since he lives 40 miles farther away. Eduardo travels 5 miles an hour faster than Maria. Find their average rates. Read the problem. We must find both Maria's and Eduardo's average rates. So we'll go ahead and assign some variables here. We're going to let x be Maria's rate, and then x plus 5 equals Eduardo's rate, or we could even call rate, some books call it the speed. So Eduardo is 5 faster than Maria. I always like to set up a table too whenever you do these distance problems. So always set up the old rate times time equals distance in the formula here. And usually we always compare two things, in this case Maria and Eduardo on the left. Go ahead and let's find an equation here using the fact that Eduardo's distance traveled exceeds Maria's distance by 40 miles here. Now let's back up real quick here and notice in our chart that Maria's time was 2 hours and Eduardo's is 2.5. So the distance here multiplying would be Maria's distance 2x and Eduardo's is 2.5 times x plus 5. So since the distance they're traveling here is going to be, so it says since Eduardo's distance traveled exceeds Maria's distance by 40, we're going to go ahead and add 40 to Maria here and set these two equations equal. And we'll go ahead and solve this, and when we solve by distributing here, we're going to have 2.5x, and 2.5 times 5 is 12.5 down here. Taking the letters left and the numbers right, if we subtract 2x from both sides of this equation, we're going to get 0.5x equals 27.5, so x would be 55 in this example. Maria's rate of travel is 55 miles an hour, and Eduardo, of course, who is 5 miles an hour faster than Maria, is 60 miles an hour. So if you want to check this, well, it says the diagram shows the conditions of the problem are satisfied. Since Maria's distance, 2 times 55 is 110 miles, and Eduardo's distance is 2.5 times his speed, 60 is 150 miles, it shows that Eduardo indeed traveled 40 miles farther than Maria. So it even makes sense when you plug everything back in and check throughout the chart. Okay, next up we're going to do some mixture problems. Boy, and I tell you, if you take chemistry classes and so forth, you will find that mixture problems are huge. So it says in mixture problems, the rate of concentration is multiplied by the quantity to get the amount of pure substance present. The concentration of the final mixture must be between the concentrations of the two solutions making up the mixture. So in this case, we're going to look at example 3 here. Charlotte Beach is a chemist. She needs a 20% solution of alcohol. She has 15% on hand as well as a 30% solution. How many liters of 15% solution should she add to 3 liters of 30% solution to obtain her 20% solution? Now, what I like to do on these type problems here, before I get ahead to the equation, I always like to draw some beakers, like we're mad scientists here in chemistry class. So I'm going to go ahead and I'm going to draw some beakers here, and we're going to see if this makes sense to y'all. We're going to go ahead and label this mixture. We're going to pour these 2 beakers together to get a mixture in this 3rd beaker. All right, now it says over here she has a 15% solution on hand as well as a 30% solution. So we're going to go ahead and put 15% in this first beaker, and I'm going to make that into a decimal and call it 0.15. And 30% I'm going to go ahead and put in this second beaker here. So if we add 15% solution and 30%, we mix something weaker with something stronger, we will get something in between, which we will call a 20% solution. So you always are going to have something stronger and something weaker to get something in between. Now, whenever you set these type of mixture problems up, do you know how much 15% that she has? Well, let's keep reading here. It says actually what we're after. How many liters of the 15%? So we don't know that, so we're going to call this X liters. And then notice over here, it goes on to say, should she add to 3 liters of 30% solution? So in this beaker, we know we have 3 liters. to get her 20% solution. So here's what students don't see is if you have X liters in this beaker and you add 3 liters to X liters, the combined result over here in this third beaker will be X plus 3 liters. And a lot of these have the same format, you see. So whenever you're setting these up, now we can write the equation here as the percentage times the amount in the first beaker plus the percentage times the amount in the second beaker here equals the percentage times the amount in the third beaker. And then it's just a matter of solving for X. So here we go. We'll go ahead and show you here that multiplying and distributing and so forth will lead us to the answer X equals 6. Thus, 6 liters of 15% solution should be mixed with 3 liters of 30% solution, giving 6 plus 3 or 9% of 20% solution. So this answer will check. If you look down here, it'll say 0.15 times 6 plus 0.9 will come out to be 1.8, as will 0.2 times 3 plus 6. So if you look at these questions carefully, they will check. Right, now it says in this problem, we'll go on here, trying to give you lots of examples of word problems and so forth, because students have a lot of trouble setting these up. So hopefully if I show you enough examples, when you see one similar in the homework, you'll be able to succeed. All right, now it says in mixed investment problems, multiply each principal by interest rate to find the amount of interest earned. So here comes the old interest formula that we have seen in other videos. So here it says an artist sold a painting for $410,000 and needs some of the money in 6 months and the rest in 1 year. Treasury bonds are available for 6 months at 4.65% and one for a year at 4.91%. A broker suggests that the two investments will earn $14,961. How much should be invested at each rate to obtain that amount of interest? So here, we must read the problem, and we must find the amount invested at each rate. So again, we're going to set up a chart here, and we have to call X something here. So let's call X the dollar amount invested for 6 months at 4.65%. So notice we've got interest and time here, amount invested and so forth. So notice at the 4.65% interest rate in time in years, we're going to call that 6 months 0.5 here. So be careful when they give you certain units here, because y'all know when you invest, it's usually in years. And then since we have $410,000 invested totally, the remaining amount must be 410,000 minus X is going to be the amount invested at 4.91%. All right, so notice here, we're going to say that interest equals principal times rate times time. So this would be the 4.65% amount. Notice we changed 4.65% here to a decimal, 0.0465. And then for the other amount, 4.91% down here, we're going to go ahead and say that's 410,000 minus X, and this is for 1 year. So those are our two interests earned over that quantity of time. So to set up our equation here, we're going to say that the 4.65% investment is going to be as shown, plus the 4.91 investment is the other 410,000 minus X equals the total interest. Now here's where it's nice to be able to use a calculator in the class. So when you distribute some of these nastier problems here, you'll crunch some numbers and so forth, and we will find out that X equals $200,000. So the artist should invest $200,000 at 4.65% for 6 months, and $410,000 minus that, or $210,000 at 4.91% for 1 year to earn that much interest. And of course, this will check, because if you take the 0.5 there times 200,000 times the 4.65%, you'll get 4650, while the remaining amount will give you 1 year 210,000 at 4.91% interest, 10,311, and notice that will total the correct amount of interest. So we got to look at several examples here of different types of linear application problems. I hope this helps your cause. Bob Young signing off. Another instructional video for your pleasure.